Hello, everyone. We're just going to wait for everybody to arrive. So we'll start in just a minute. We're going to let everybody load in here. Can everybody hear me okay? Great. Okay, good. All right, we got a lot of people. This is great. Okay, so we'll get started in just a minute. I'm just gonna give everybody one more minute just to arrive. I see a lot of familiar faces. It's good to see all of you. As you can see, I am not in my office. We are going to be doing a sort of a little mini field trip. So we'll see how this goes. I have not done this class before online. I've done it many times for students here, but this is the first time I've done it online. So I hope this goes well. You can feel free to ask me any questions. You should be able to just see me, George. So it's just gonna be me and I'll be talking to you, and that's how this is gonna go. So what we're gonna do is this class is called Computer Basics, and we teach this class here at the school to students who have they're just at the beginning of their high school program, and but I've taught this to kids all the way down to like 6 or 7 years old. So we're gonna cover it as if you have never learned this before, and so I know some of this information is going to be some of this information you will already know, because I know a lot of you know a lot about computers, because I've seen some of you in my coding classes that we've done, and so I know that you know stuff about computers. But we're going to talk about some really basic stuff that not a lot of people get to learn about just directly. You might kind of sort of hear about it and sort of figure it out on your own, but we're just going to talk about it directly and fill in any holes that you might have that you might have. So first off, we have lots more people who have arrived. Hello, everybody. I see lots of people arriving. This is great. Even hello from Pakistan. Hello. April, I see you there. Great to see. Denali. Okay, good. So we've got a lot of people. If you just joined, we're going to be talking about some computer basics. And like I said, some of you I know already know some stuff. So even if you already know some stuff, still listen to all the things we're talking about, because you may find a few pieces that you might not have known before. And I know there's some things that are going to be new to all of you, and that's for sure. But I just want to make sure everybody's not like, oh yeah, I know this, and then you don't end up hearing something that might be useful. Okay, so let's get started. So what we're going to do is we're going to, so for teaching computer basics, it's good to know what is a computer. Like, what do we consider a computer? Because we have lots of things that we look at all the time that we think about as computers. Like, for example, like here. So we have these computers here, and you can see there's a mouse, there's a keyboard. It's a pretty standard thing that you would look at and you'd say, oh, that's a computer, right? Well, yes, it is a computer, but there's lots of other things that qualify that can be counted as a computer. And so to answer your question, Montel, yes, I do teach computer 3D modeling, not in this class, but I do teach it. And we also have a summer camp this summer doing that as well. So there's four things that need to be there in order for something to be called a computer, okay? And we're gonna go over those four things. So the first thing is something called input. And that means you can get information into the computer. And there's lots of ways to do input. So I'm gonna go around and we're gonna look at a few different things that are considered input. I'm gonna switch my camera here so that I can point it at things. Okay, So here's one thing. A lot of you have used this before. It's a mouse. When you use a mouse, you're telling the computer where you want to click, and that's input, okay? You're sending information into the computer. Obviously, a keyboard, that's definitely input, because that is, you know, you're typing and sending information into the computer. So that's obviously input. So input is just getting information into the computer. Now, there's other things that are input. So for example, if I have my phone, let's see, I gotta make sure I can see my phone here. So if I have my phone here and I'm touching the screen, that's also input, okay? So let's look at some other input. So let's say we have this printer here, okay? See how I can touch the screen and it does things, right? That's input. So on the front of this computer, I'm gonna go over here, and you can see on the side of this computer, I'm gonna angle it down here. There's this button here. That's the on button. That's also input. You're telling it's very basic input. Yeah, so sometimes like, Kanan had a point, like, you know, you have like a USB stick, like here, I've got one on my keychain. So see this USB stick where you can plug it into the computer? That's also input, because you're putting files into the computer. Okay, so I'm gonna switch it back to me for a sec. Okay, so we have lots of ways we can do input, and input can be really simple. It can be just like a button, or it can be a touch screen is also input. You can also have a keyboard or a mouse, lots of things. Some things have like a dial, you know, that's also input. So now we're gonna go to the next thing, which is, obviously, if we have input, we also have output. And output is really just anything that the computer uses to give you any information. And it can be really simple. Sometimes you just have like a little light on the front. That's output. That's telling you something. Is it on? Is it off? Is something working? Like if it's blinking, sometimes that's useful information. Sometimes if it's blinking, that's a bad thing, but it is still telling you information. So that's output. So output comes in lots of different ways, from as simple as a blinking light. It could also be it could be on like a computer screen is output. If I have my phone, so just as I was touching my phone and that's input, the screen itself that's showing me things is also output, okay? So a camera, like a camera on a phone, that's also input, because you're receiving information for what's around you, okay? Now the screen that shows the camera, that's output. And so there's lots of different things that can be considered output. So let's take a look at a few things. Okay, so I'm gonna switch my camera here. Okay, so like on this printer, this little screen is output. Now remember, it's also input because you can tap on stuff and it actually works, you know, so that's input. But the fact that it's showing us stuff, that's output. This, oh wait, where was it? This right here, see this light that tells us that the printer is on? That's also output. Okay, so let's look at what else. So if you look on the side of this computer, see how there's that light there and one of them's blinking? That's also output. And then on the keyboard, you can see there's a light that says whether the caps lock key is on or off. That's also output. All right, so now I'm gonna handle a couple different questions. So hold on one sec, let me switch my video here. So April, you mentioned a mouse pad. So that's close, but it's not connected to the computer. So it's not actually part of the computer. You can use the mouse, which is part of the computer, on a mouse pad. So it can help make the input better. But by itself, it's not actually part of the input. Okay, good. So now we're going to look at two other things that make a computer. Because if you just have input output, that doesn't really make a computer. Because you think about a flashlight. Like a flashlight, you have buttons, right? It has a button on the side, and it has, so that's input, yeah? And then you have output, which is the light itself. But a flashlight's not a computer, it's just input and output. So there's something else that makes something a computer. And the first thing is it can store information. So that's really important. Can it store information? And Gerard, we'll get to that question in a sec. So, but storing information is really important because it doesn't have to be like you can store like DVDs and movies and, you know, music and files and all this and games and all that kind of stuff. It can just be really simple. Like, I'll give you an example. Let's take, like, we're going to walk over here. I'm going to walk over to a thing on the wall here. This is a thermostat. A thermostat controls the temperature of the room. And you can see it's off right now. But on this thermostat, you can set a schedule. And you can say, okay, from 8:30 to 5, the temperature should be 50 degrees, or I mean 70 degrees. 50 would be really cold. But so you can say, from this time to this time, that is what the temperature should be. And it's storing that. So that's storage. It's storing that information. Yes, that's right. Kanan, you said that a computer stores data. That's correct. Is there a button that turns the device on or off? What would that be? So a button is usually input because you're sending information into it. So like if the buttons here, these are all input because you're telling it, you're sending information into the computer and you're telling it, do this thing. And that's important to realize is input is when you have some way to tell the computer something, or you can give it information. And sometimes if the information could be as simple as turn off, you're telling it turn off. So how do you tell it? Well, with a button. So that would be input. So Gerard has a really good question, which is, are data and information the same thing? And for most people, there's not really a big difference between data and information. Now, you can get a little more exact about it, and data is the things you collect about something. But information might be what you know from having collected that, right? Like for example, let's say we kept a list of how many trees were cut down this year and last year and the year before. Okay, that's data. That's like, okay, there were this many trees in April, this many trees in March, this many trees in February, this many trees in January. That's data. Now, information is there are more trees getting cut down this year than last year. That's things that we know because of the data that we collected. So it's a really kind of close difference between data and information, but that is definitely a difference between them. So let's go back to storing information, okay? Because this is a really important one. So storing information, we'll get to that question in a sec, George. So storing information is just where the computer can keep information. It doesn't have to be a lot of information. It could be really simple. It could be just like a schedule of like when the temperature should be at what temperature. But it also could be like all of Wikipedia, or it could be, you know, like DVDs and, you know, music, and I mean, it could be tons of stuff, but it could be really simple or it could be a lot. It's just whether it is storing information. Like a flashlight doesn't store any information. It's either on or it's off. Once it's off, there's nothing there and that kind of thing. Okay, so that's the third thing. So we have input, we have output, and we have storage. The fourth thing, and this is the real key one, is can it calculate things? And now calculate things is kind of a broad term, but it really means like, can it do math? You know, can it figure out problems? And sometimes it can be hard to realize whether something can calculate or not. So we're going to talk about a couple different ways. Okay, so for example, let's take a look at something on the wall here that all of you have seen before, and it's a clock. Now this is a really basic, I'm gonna wait for my camera to get better here. So take a look at this clock. Now this is not a really complex device. It tells time, right? So would we consider this a computer? Well, let's compare it to the 4 things that we know about. It has input, right? Now on the back are buttons. So way back here behind it are buttons to set the time. That's input. Now output, well, what are some of the things that it has for output? Go ahead and put in some answers, some of the ways that this has output. You can put in the question and answer part. What are some ways that this clock has output? Yes, so it has the time on the screen. That's correct. It also tells us what day of the week, and it tells us the temperature, and those are all output. It tells us the time on the screen. So the screen itself is output. That's correct. Now, what does it store? It does store some information, because if you look, it's got, like, if it's storing the month and day, you know, and it's storing the time zone that it's in. So it has some way to store things. Now can it calculate though? Well, yes, it can calculate, because see how it says it's Wednesday? How does it know that it's Wednesday? Well, it takes the date and it uses calculations to figure out, okay, because it's this date, it must be this day of the week. And that's calculation. Even though it doesn't seem like a big, fancy, complex calculation, it is calculating. It also has to calculate how quickly does it switch over to the next second, and it has to calculate that. And it also, I don't know if you can see, but you see the little sort of, it looks like a Wi-Fi symbol up in the corner. This clock actually has a radio, and that radio, the radio in the clock is input, because it's receiving a radio signal that says what time it is. And then it takes that radio signal and it calculates, okay, the radio signal I got should equal this time. So that's calculation. That's right, Gerard. So it calculates temperature, time, day, and date. Those are a lot of things it calculates. Now, obviously not as much as, like, say, your phone or an iPad. It's not calculating as much as that, but it is calculating. So that would be considered a computer. Now, the thermostat thing that we looked at that has, you know, keeps the temperature, the right temperature, it's got to calculate, like, okay, based on what time it is and the temperature in the room, should I turn on, should I turn off? It's got to calculate, you know, okay, if it needs to be this temperature by this time, how early do I have to turn it on, you know, that kind of thing. So there's lots of things that it does calculate. So those are the 4 basic things that make a computer a computer. It has input, it has output, it can store information, and it can calculate. Now, computers today do a lot of calculation. I mean, a lot. So think about how many math problems you can do. Like, if I just fired off math problems to you, like 8 plus 3, 2 times 4, 3 plus 9, and I just like fired off math problems, how many do you think you could do in a second? Like, how many math problems do you think you could do in a second? Just go ahead and tell me. I think I could maybe do 2 per second. Like, if I got really good and I was like practicing a lot, I could probably like do 2 a second. 0 to 1, okay, 0, okay, so 1, maybe 2 per second. So that's, you know, not a lot, right? But that's still pretty fast for a person. You know, you might get a math genius who can do, like, you know, maybe 3 per second. That would be a pretty fast person at math. So yeah, it also depends on the problem. Some problems you wouldn't even be able to do in a second. It would probably take you, like, you know, a few minutes or maybe an hour, right? So, but I'm talking about like real basic arithmetic, like addition, subtraction, multiplication, division. So a computer can do a lot of calculations per second. So a normal computer these days that, like, let's say you go to the Apple store and you buy a computer and it's, nothing, doesn't even have to be something fancy. It could just be, like this computer here, this is, it's not a bad computer, but it's just a basic computer. We have lots of computers in here, right? So these computers can do so much math per second. These computers are pretty normal computers, and they can do 4 billion math problems per second. 4 billion math problems per second. That is a lot of math. If I did math for like the rest of my life, I might be able to do as many math problems as a computer can do in 1 second. And so that's pretty good. Yeah, it is. Yeah, it's insane. It's a lot of math problems. We kind of go, oh yeah, it's faster than last year, but we don't really think about the fact that like that's a lot of math. And each computer, like this one here, does like billions of math problems per second, and it's in my pocket. Like that's pretty cool. Okay, so let's talk about how computers talk to each other, because it's really cool we have these computers. And if you think about it, we have a lot of computers that you might not think about. Like for example, like in a car, most all cars nowadays have a computer inside them. And the computer is helping run the engine and so forth. And if you go to get your car repaired, a lot of times to figure out what's wrong, they plug a computer into your car's computer, and the car's computer says, oh, it's this thing. This is what's wrong, and this is what needs to get fixed. Or it says, here's the things I know about how the car's running, and then the mechanic might be able to figure out from that, like, oh, let's go take a look at this. But a lot of times they're figuring it out by plugging it into the computer that's in your car. It's like in the engine. So it's even things that you might not think about as being a computer are computers. And so I'm going to walk around and show a few things here that you might not think of as computers. We already talked about, the clock up on the wall, how that's a computer. We also have this printer is also a computer because it has input. You feed paper in. It has a screen with buttons. It has output. It has paper that comes out with things on it. It has a screen here, and it also has lights. Now, so this would be considered a computer. Even though we call it a printer, it's still a computer, and it's run like a computer. That thermostat on the wall that controls the temperature, also a computer. Even though it's a small one and it just has a few buttons, it's still a computer. My phone in my pocket is a computer. Lots of things that you might not think about are computers. You can use those 4 tests to check and see, is it a computer? Would it be considered a computer? Okay, so that's right, April. So iPad also has output because it has a screen, right? You can also plug headphones into it. So the headphones, that's output. Sound, having it give you sound is output. It has speakers too. That's speakers is output. Okay, so now that we have an idea that there's lots of things that are considered computers that you might not normally think of as computers, let's talk about how they talk to each other. Because it's handy to have a computer, but it's really handy if the computers can talk to each other. So for example, if I sit down at this computer behind me over here, actually over there, I would want to print to this printer behind me. So how do we do that? Well, if we go look, so this is where we start getting into doing a field trip, okay? So I'm gonna show you the back of this computer here. We're gonna look back behind it. And do you see this blue cable coming out of it? It's this one here. This blue cable coming out of this computer, that cable is called a network cable, okay? So that allows it to connect to other computers. Gerard has a good point. So computers can calculate 4 billion math problems per second, but we can't type that many problems that fast. That is true. So now I want to show you the back of this computer that we call a printer. Okay. So, oops, I may have to go around the other side because my camera from my computer is on the other side. So do you see that blue cable coming out of the back of this printer? And that blue cable is the same as this blue cable in the back of this computer. So you can see we can connect up two computers via wires. But that's cool. But if you look at how many computers do we have in this lab, we have a lot of computers. We can't just like take each computer and plug it into this printer. Otherwise, this printer would need like, 20 cables plugged into the back, but you saw there's only one cable plugged into the back. So how does this work? Well, all of these computers are actually connected together into one place. And then there's one cable that comes over here. Now let's go look at that place and let's go see how all these computers can talk to each other if they're all have a cable plugged in. Let's go take a look. So this closet has something in it, and we're going to look in this closet. Look up here. See all those cables? All those cables are coming from all the computers in the room. Now you see this thing on the shelf? That's a computer. It doesn't look like your regular computer, but it does have input, output, and it calculates because it figures out where the signal from one cable needs to go to another cable. And it also stores information because it has to store information about how to send those signals, right? So it has input with all the cables plugging in. It has output with all the cables plugging in. It also has output from all the little lights. The lights tell us information. So April wants to know, how does it know how to send signals? Well, that's where computer programming comes into play. People who know how to give computers instructions figure out really neat ways to make information coming from one cable to know how should it go to the other cables. So I'll stop for questions in a sec. I just want to finish this one part, but I want you to see one of these cables is coming from the printer and going into this computer here. So one of these cables is from the printer and the rest of them are from the computer. So if you see how that works, you can see how we can have all of these computers in this room can all talk with one cable to this printer here because they're all connected through that computer in the closet. That's pretty cool. And that allows us to have lots of computers all connected at once. Now, when you have a bunch of computers all connected like that with cables, that's called a network. Because networks is when you have things that are connected to each other. It doesn't have to be computers. You can have a network of people where people all talk to each other. Like if you have a group of friends, that's sometimes called a network of friends because you're all connected to each other and talking to each other. So a network of computers is when you have all the computers connected to each other and they're talking to each other. So I'm going to answer some questions now. So George had a great question. Is a TV a computer? Well, let's think about it. So the TVs nowadays are mostly all computers. A long time ago, the TVs weren't necessarily computers. They didn't really calculate anything. They had input, they received signals out of the air, and then they had output because they could show you stuff on the screen and they had speakers, right? So they had input and output, but they didn't store anything. You just, you had like a dial you could change, but it didn't really store any information. And it didn't really calculate any information too. The input just got turned into output. And then so it wasn't really a computer. But nowadays, most TVs are computers. And if you notice, you have like a remote, that's input, right? And the output is the screen. But most TVs can connect to Wi-Fi nowadays. That's input and output, right? I mean, it can connect to Wi-Fi, that's for sure. And it can do things like you can add Netflix to your TV, or you can have different cable channels, or you can have Hulu, or you have lots, or Amazon Prime. You have lots of different ways to watch movies, and those require computing to figure out how to do that. So in that case, the TVs nowadays mostly are computers. And so another question is, we can connect a computer to a computer via wireless, right? Yes, we're going to get into wireless in just a second. So another question is a car or computer or its car battery is the computer? So the car has its own actual computer. It is its own computer inside. The car battery just provides the power. It just provides the electricity that the computer needs to run in order to do its job as a computer. Most computers, I'm not going to say all, run on electricity. There are some computers that do run on other things. Like I've seen a computer that runs on water, and I've seen another computer that runs on air. I even saw one computer that runs on sugar in your blood. Like, that's amazing. That's really incredible. But most computers run on electricity. So if you add Netflix or YouTube or Hulu, that's storage. Well, yes and no. It has to store your information. Like, it stores your username and it stores your password and it stores it stores information about those services like Netflix and Hulu. So in that case, you're storing information. It also has to store the program that can go talk to Netflix and show you videos and things like that. So that also is storage. It's storing the programs itself. Okay, good. So, all right, so now so we talked about wired. We talked about how all these things are wired up. And so now let's talk about wireless, okay? Because this is a really big thing that a lot of people kind of know. They kind of know it, but if you really ask them, it would be hard to give a good answer. So for example, no worries, Evan, that's not a problem. So April, yes, your headphones have input and output. An AC system, so Ben had a good question, is an AC system a computer? Sometimes it is. And actually most of the time nowadays it is, because most of the time it stores like the temperature settings that you're using, and it has to figure out stuff of like how to, based on the sensors, which are inputs, the sensors are inputs. Does it calculate like, okay, when do I turn the temperature on or off and that kind of thing? A lot of AC air conditioning is a computer. Okay, so Ananya asked, so anything that can store data, have input, output, and can calculate are computers? Yes, that is correct. If you can store data, it has input and output, you can consider it a computer. Per the definition that we're talking about, yes, that's correct. In the computer, so let's talk about wireless, and then I'm going to talk about one other thing. So wireless, so we have all these computers that are wired together, right? That's useful, but not all the time, because sometimes it's hard to make a wire go from one place to another, and that can be tough. Okay, it's tough to put wires everywhere. It's also messy, sometimes you just don't want wires everywhere. It's annoying. Like if you look on this wall behind me, you'll see this thing right here that goes up the wall that has wires inside. Well, I'd rather not have it along the wall if we didn't have to, but we kind of do need it in order to add wires. So we have something that we use to connect computers without wires. It's called Wi-Fi, okay? But what is Wi-Fi? Like, I know we need it to connect things. And, if you have Wi-Fi, usually you have internet, but what does that mean? Like, I have Wi-Fi. Like, what is Wi-Fi itself? Anybody have a good answer for that? It's not an easy question. It's something like you can say like, oh yeah, my laptop's on Wi-Fi, or my iPad's on Wi-Fi, or my phone is on Wi-Fi. But what is Wi-Fi? A lot of people never find out. And that's part of what we're going to answer. Okay. So have you ever been in the car and you're listening to music on the radio? Where's the music coming from? Well, it's coming from the radio, right? Well, there's radio signals that are going through the air there's a big radio tower and it's sending out signals. and your car gets the signals and then it turns it into music and plays it out the radio, right? That is a radio signal that goes from the radio tower out to your car, and then your car plays the music, right? So Wi-Fi is just radio signals from your device to other devices. That's what Wi-Fi is. It's just a kind of radio signal. And it's not as powerful as like what you get in your car, because that goes over like miles and miles and miles. And I know some of you, if you go to like the other side of your house, the Wi-Fi is not so good. So it's not as powerful, but it is still the same thing. It's still radio signals that go back and forth. And so I'm going to show you some of what that looks like. I mean, I'm not going to show you radio signals because I can't show you radio signals. They're invisible. But I am going to show you something up here. So I'm going to show you up on the ceiling here. So we have a projector, which is also a computer, by the way. So we have a projector, but look up here. See this little bubble on the ceiling? If we look back here, it's not that big. It's pretty small. We'll wait for the, here, I'm going to turn the lights off so that it doesn't, so it's a little easier to see. I think maybe it'll be easier to see, maybe not. Okay, kind of easier to see. There you go. That little bubble on the ceiling is sending out radio signals. So let's tilt it this way. So that bubble is sending out radio signals to my phone, and my phone is sending radio signals back. So my phone and that little bubble on the ceiling are talking to each other. Now I want you to notice what's coming out the back. What's coming out the back of that bubble? A wire. And that's how it knows what to send, what information to send out over the radio signals. So that wire is where it's getting its information. And that's why if I'm on my laptop here, like I'm on my laptop right now, you can see me here, I'm on my laptop. I can tell from my computer, I can say, okay, go print. And it sends it up to that thing on the ceiling, sends it up there, which then sends it out its wire, and then sends it down to the wire that's coming out the back of the printer. So that's how I can print from my laptop, which is not connected to anything. I can print to a printer that's somewhere else because it's going first over radio signals. And once it gets to the radio signals, once the radio signals get up to the device that's in the ceiling, that sends it on to the printer. Now that bubble thing is called an access point. It's a point where you can access Wi-Fi. And a lot of times they have names, and usually when you pull up your phone and it gives you like a list of things to connect to, you're looking at the names of those things, those devices that are sending out radio signals. And so when you go to a coffee shop or something like that, they'll usually have one somewhere. You might not be able to see it because they might tuck it away somewhere. Sometimes you can see it though. And so I'm gonna walk around and we're gonna look at some things. Now, I wanna tell you, because I'm walking around the building, my computer has to change which bubble it's sending the Wi-Fi signal to. So my connection might go, it might come in and out as my computer figures out which bubble it should be sending, which access point it should be sending its Wi-Fi signal to. So we may get a little, interrupted here. So we're gonna see, all right? But we're gonna go look around. So, so Ben had a good question. What about Bluetooth? Bluetooth is also a radio signal. It's just it's not as powerful as Wi-Fi, but it's also a little radio signal. And so your phone actually has several different radios in it. One's radios for Bluetooth, one radio is for Wi-Fi, and one radio is for cell phone signals. Okay, so we're gonna look around. So we're gonna take a field trip here. So remember, we looked at this computer that's in the closet. That's how all these computers in this room are connected to each other, right? Okay, so now what we're gonna do is we're gonna take a little field trip out to another room. However, because this room is all empty, where did it go? This room is all empty, so I don't have to wear a mask. But because we're gonna go out where there's other people, I'm going to be putting my mask on. So I'm going to still try to talk as clearly as I can. But if you can't understand something, you just have to tell me. I'm going to try to talk as clearly as I can. But I have to put a mask on because we're going to be around other people. And that's just a good idea to do these days. Okay, and hopefully my glasses don't fog up. Okay, are we ready? Here we go. So we're going to go to a different room, and we're going to go over here, and you can see there's other people here. So let's go in this. Oh wait, we're going to go over to this room here. So in this room, this is a room they do classes in sometimes, but I want you to look up on the ceiling. See the access point? So anybody in this room that's using Wi-Fi, their computers would be connecting to that thing on the ceiling. And that's how anybody in this room can use and talk to other computers without having to have a wire connected to their computer. Now, if you look at that computer, I'm going to switch my video here. We're going to look at the back of this thing. If you look at the back of this, you see what's coming out the back? I'm going to try to make it so it gets in focus there. Let's see. Can it get in focus? Oh, come on, you can do it. All right, it's not totally in focus, but you can see coming out the back are wires. And those wires go over to that closet. So that's how all those places connect. So now we're going to switch. I'm going to switch the camera. All right, so now I'm going to move to a different spot. I'm going to move to a whole different spot of the building. So my Wi-Fi might disconnect for a sec while it connects. So we'll see how this works. I'm going to try to go slowly so it doesn't disconnect too badly. But here we go. We're going to take a walk. We're going to go downstairs to a whole different floor. Here we go. Hello. Okay, so now we're going to go into a whole different room here. This is on a different floor of the building. So I'm going to get my keys out because nobody's in this room. Because nobody's in this room, I'll be able to take my mask off. But okay, here we go. Hopefully we're all still connected. All right. So we're in a different room of the building on a different floor. And I'm going to switch the camera here. Okay, so this room, you can see it has a printer and a computer. And if we look behind them, you can see there's the cable coming out of the printer. So this printer is connected by a cable, but it's not connected upstairs. It's connected down here. We can say hi to Melissa. Hi, Melissa. So you see, she's got her laptop on her desk, right? No cable. So how's she connected? Well, she's connected through Wi-Fi, but where? Because we're pretty far from the computer lab, so there's no way she can connect to that one. If you look up in this corner up here, there's a little shelf. Now, because you're on a laptop, I can lift you up way higher. But do you see that bubble on the ceiling there? And there's a bunch of cables. All of those are where the computers in this area connect to. So that little thing up in the corner, up here, that is the wireless access point for this whole area. So all the students in this area can connect there. That's how Melissa's connecting up to that via wireless. So that thing up there is connected to all these computers here. But sometimes I want to be able to connect to computers upstairs from computers down here. So how do we connect these computers up to those computers? Those computers are all connected together. These computers are all connected together. So how do we connect the two together? Well, and then we're going to go to a different room and see that. So I'm going to put my mask back on because we're going to a different part of the building. Here we go. Now this might get a little loud. Hello. All right, here we go. All right, we're going to go into this room here. This is a room that not many people get to go to. I'm gonna turn on the lights here. Okay, I'm gonna switch my thing here. I'm gonna close the door so I can take my mask off. All right, can everybody still hear me? Is everybody still connected here? Amber had a good question. Can dogs see Wi-Fi because they can only see black and gray colors? Or is it completely invisible? It is completely invisible. They cannot see Wi-Fi. Okay, so I'm gonna go open this up here. So this room here, whoa, look at all the cables here. That's a lot of cables. And see those computers? Those don't look like normal computers. They look more like the ones in the closet. These are the computers that connect all the computers in the school. All the computers in the school, each one of those areas, like that closet, has a cable coming down here. Every area of the school, that central connection point connects into this room. So this connects all the computers in the school. Okay. Oh, George cannot hear me. Well, this is a loud room, and I apologize. So I'm going to try to go into a quieter space, okay? So let's go into a quieter space. I'm going to close this door because it's pretty loud. Okay. I hope you all can hear me now. So that place that we just saw, that's where all the computers in the school connect down to there. Now, they don't all connect. Like, not every single computer has a wire that goes into that room. Because as we saw, they have wires that go into one connection place, and then those connection places all connect down here. All right, so my screen is lagging. I understand because I'm in a weird area of the building. So I'm gonna move, and I'm gonna give it a sec to get better. So I gotta put my mask on. Okay, here we go. We're gonna go upstairs. We're gonna go back upstairs to the computer lab. All right, one sec, here we go. Hello. Okay, we're gonna head back into the computer lab. So we're gonna finish up the rest of this here in here. All right, we only have a few minutes left, so I wanna finish this up. So I'm gonna draw something on the board, and hopefully you all can see it. I gotta get a marker though. I hope this has been interesting. This has been fun for me to show all this to you, because it's something that not everybody gets to see all the time, but we use this stuff all the time. Okay, so we had all of these computers. All these computers were connected to each other in one place with that computer in the closet, okay? And then we had another area with a bunch of computers. And those were all connected to a computer on a shelf, right? So those are all connected to each other. Can everybody see me okay? I just want to make sure I'm still connected here. Can everybody see fine? George, you can't see me at all? Some people can. Some people can't hear me. So I'm gonna give it a sec to like settle down because I just moved to a different place. So it's reconnecting to the Wi-Fi on the ceiling. So I'm gonna give it a sec. How about now? Can everybody hear me now? I know some of you, it's hard to see. Okay, good. So it sounds like most everybody. So even if you can't see, if you can hear me, I'll try to do it as if you can hear me, maybe not see me. So we had all the computers in the computer lab connected in one place in the closet. And then we have all the computers that were downstairs connected to that one place on the shelf. And then we saw that big room with lots of big computers, and they were all, and all of these things were connected to each other. And these went out to lots of other things. Okay, so all the computers in the school connected to that one room. So how do we connect to everybody else out in the world? Well, our computer in this room, that one that we saw with like tons of cables and stuff like that, has its own connection out of the school to a company called an internet service provider. And what they do is they connect up lots of people to each other. So like our school is connected to the internet service provider, and then other schools are connected to that internet service provider. So we can talk to other schools, other businesses like coffee shops and insurance companies and, you know, all sorts of stuff, police departments, fire departments, and all also connected to the internet service providers. So then we have, so I'm going to move this over here. So now we have this internet service provider and this internet service provider, and they're all connected to each other. So we have lots and lots of things all connected to each other. And that is the internet. All those companies connected to each other. And in those companies, all the computers connected to each other, all those things connected together, that makes the internet. It is just all the computers connected to each other. So anybody have a question on that? Because that can be a tough one. But if I take my phone and I connect it on Wi-Fi to other computers, I just made the internet one computer bigger. If I turn my phone off, the internet just got one computer smaller. If I turn my laptop on, I connect it to other computers on the internet, I just made the internet one computer bigger. And the size of the internet, okay, so it says my screen is constantly lagging. Is it doing that for other people? If I go back here, does it work better here? How about now? Is it working okay here? Okay, so I'm going to finish up real quick. This is the last thing. So all these computers that are connected together, when they connect to other computers out in the world, that makes the internet. So when you turn on your laptop and you connect it up to internet, to other computers on the internet got one computer bigger. And when you turn your laptop off, the internet got one computer smaller. If everybody turned off their computers, even the big computers that we saw down in the closet, the internet would be gone because there'd be no computers connected. That's what the internet is. Just all those computers connected to each other. That's what makes the internet. Okay, good. So I do apologize for some of the lag because I had to move around and sometimes the Wi-Fi doesn't connect correctly. So what we will do is we will have this, as a recording that will go up on YouTube. So hopefully you all can watch it because we are out of time now. So Gerard had a question. Why does Delphi prefer wired Wi-Fi than wireless Wi-Fi? So Wi-Fi means wireless. So you can have all those computers connected via wires and still connect to other computers, and that's still considered internet connection to have them up to other computers in the world, even if all you're using is wires. Now, Wi-Fi is when you're using that radio signal to connect without wires. And we actually prefer Wi-Fi here. So we have those little Wi-Fi access points, the things we connect to, all over the school, in the dorms and out at the houses and in the building, all in the rooms all over the place. But the computers in the lab need really strong, fast connections. And you can get much faster connections with a wire than you can with wireless. So that's why we use wired in the lab for the lab computers. And a lot of office computers are done that way too. But then we use wireless, we use Wi-Fi for laptops and phones and all that kind of stuff. So I hope that answers that question. The YouTube channel is, I believe it's youtube.com/the Delphian School. If you search for Delphian Online Learning, I believe you'll be able to find it. You'll be able to, on YouTube, you should be able to find it. And I don't know how fast it goes up to the internet, but, or gets uploaded to YouTube. Wireless connections, Ben has a question, is it because wireless connections are more open? Well, they're just easier, just because you don't need a cable. You can just like turn it on and have it connect and it works. So unfortunately, we're out of time. Hopefully we'll do this again, and I'd be happy to answer more questions. Thank you everybody for watching. I had a lot of fun showing you all of this. Sorry for any of the lag that happened. Hopefully it looks fine in the recording. Okay, thanks everyone. I have to go because we have another class coming up. All right, bye-bye.